So we are going to conduct binomial experiment to determine the probability of two coins landing on heads. A head or heads, I guess the two heads. Compare the theoretical probabilities, and I guess I should have said with the experimental. Okay. So step one for doing something like this is you define the trial. Trial in this case is not like in front of a judge, but rather an experiment. You're doing different things with it. So what it is in this case, we're going to be flipping two coins, and we have to determine like how many times to do it to see what happens. So a trial for this one is going to be, or is tossing two coins, and you want to see how many times if it lands on heads. And we're going to have to do it enough times to get some data to work with. So let's say 20 times. Step two is to define a success. So a success is what it is you want to get. Because when you do this, if you do these 20 trials, sometimes you're going to get what you want, sometimes you're going to get something you don't want. So what you don't want are going to be the failures. But the things you want, those are your successes. So we need to define exactly what that is. A success is both coins landing on heads. Now, doing this, saying this seems, common sense. I mean, why do we have to write it out? It's way too easy to forget where you're going when you do these. So anytime any mathematician, scientist doing anything, they always write down exactly what they're trying to find. How they're going to do it, what their method's going to be, what they're looking for. We need to do that for these two. So this is part of the idea, part of what you learn to do when you're analyzing, dealing with data, is you have to know where you're going and know exactly how you're going to get there. So the next part here, before we actually do step three, is for this kind of problem, let's figure out what the theoretical probabilities are. So this isn't one of the steps to do the experiment, but it's an important part to know about it. Okay, sometimes this is be given to you, but in this case, it's not. So let's figure out the theoretical probability of success. So, the way I set this up, and sometimes the way something like this is set up is whatever makes sense. Here's what makes sense to me. Two coins, and it can be, you have heads on one side, tails on another for each of the coins. So, the possibilities, get that written, right? So I guess you could say H and T for one and H and T for the other. The possibilities, if you flip them both, you could get heads on one and heads on the other. So heads and heads. You could get heads on the first one and tails on the second. You get tails on the first one and heads on the second. You could get tails on the first one and tails on the second. There's no other possibilities. There's only four things that could happen. If we were flipping three coins, we would have heads, 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 tail, heads, 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 tails, and you'd have to do the same thing. But you see how you flip it three times, now you've got a lot of possibilities. Flip it four times, now you've got more possibilities. It's like going up each time. Yeah. Well, what it is actually, if you think about this, this is 2 and you square it. If we do it, this is the number of times you flip it. You have two possibilities. If you flip it 3 times, you're going to have 8 possibilities. If you flip it 4 times, you're going to have 16 possibilities. Interesting little thing. That's where the exponent helps you know how many you're supposed to have. And if I did this with 3, it could probably work because you could figure out 8 of them. 4 can too, but that's a little more than I think we're going to take time to do. Doing out 16. It's actually interesting to me. I like doing it, but I just don't think we're going to have the time. So, from this, how many successes are there? There's only one that you can have out of these 4. And that means out of 4 possibilities, if you think about it, you have a 1/4 or a 25% chance of success. So your theoretical probability of success is either 25% or 0.25. Decimals are common in dealing with probability, but the percent is something that makes a lot of common sense to us. So now, I did this here just to figure out what's the chance of the success. Of course, failure would be the opposite. There's a 75% chance that you're not going to get 2 heads when you do this. Now, what we're going to do for step 3, we're going to determine a random variable. And this seems like it's not really needed here until you start figuring out, it's part of like doing, I want to follow the steps in the book and get you used to doing that. So define the random, D-O-M, random variable x. So x is what we're trying to get to. What is it? Let's define it. Well, again, this sort of makes sense. X represents the number of successes in 20 trials. The 20 comes from defining the trial at the beginning, so we're going to do this 20 times. Okay? We're tossing 2 coins, we're going to do it 20 times. And in those 20 times, when we toss the 2 coins, we're trying to get a success of heads and heads. So x represents the number of times that we actually get that. Theoretically, it should be 1/4 of those, which is 5. Theoretically, we should get it to happen 5 times. So, step 4, we're going to use the random number generator to actually give us 20 times. So we're going to do it 20 times and figure it out. So, yeah. You can make up numbers sometimes, but this way it helps. So the interesting thing here, let's set this up with some numbers. Okay. So I'm going to use the calculator. We're going to do a random number generator. And there's one other thing we'll see if we figure out here. If anyone can tell me what I'm not purposely forgetting something, but I'll tell you why in a moment. Calculator, tests, I forgot where it was.
It's math, and then you go with probability.
This is what we do a lot on these. Some of you probably do the same thing. You're not sure which one, you press it, you look at it, realize it's not that one, it must be the other one. So it's math, and it's a probability thing. And when we did this last week, I told you if you do the rand one, you're going to get all decimals. So do the one with integer. Now, the nice thing about the TI-84CE or the NSPIRE is if you do this, it'll ask you for like how many trials, and it'll give you all the numbers at one time. Here, we're going to have to press it 20 times to get the numbers. Yes?
If you put a 3rd comma and enter however many that you can do
Well, we'll do this on here too? Okay. I didn't realize I did it on here because I'm used to not doing it. Thank you. Let's try that on here. So, wait a minute. How do I put heads and tails in here?
You have to number each one.
Number each one. That's where we're thinking. What you now have to figure out is how are you going to set this up so it makes sense to the calculator. So let's do it like this. I want this one, let's call that a 1. Every time we get a 1, that's a success. This would be 2, 3, and 4. Well, all of these are failures. All of this is success. So what we're going to do is figure out from here how many 1s we get and how many 2s, 3s, and 4s we get. And this will be our x. How many times the number of successes would be this. I guess I should say x equals here. Okay. So that means our numbers will be 1 through 4. So it's 1, comma, 4. And then I'm going to do what you said. What's that?
Try comma 20, we'll see.
I think you have to put the, yeah, let's put the 20 because I have to put the 1 and the 4 first for what's doing so.
Yep,
Yeah, so now we've got a 3. Actually, now what I could do is just go through and count how many 1s on there. 1, 2, 3 1s, 4 1s, 5 1s, 6 1s, 7. So it came up with 7. So 7 ones, and that means that there were 13 of the others out of these 20.
Wait, was it 8? I think there was the one at the end. Did you count that?
Yes, I counted that. That was the 7th one.
Oh.
Yeah. So that means we got 7. The interesting thing is that 25% of 20 was supposed to be 5. So that means what we would say are results, and I'll say, actually, let's go up here. 25% of 20 is 5. So 5 would have been the theoretical probability, but the experimental results were that we got 7. So the experimental let's say, actually now what I need to do here, because it's usually written out as the experimental probability, that means we have to figure out what this is out of the 20. So it's 7 out of 20. That was 5 out of 20 was 25%. 7 out of 20 is going to be, this one is just do it out of 20 divided, you can't, so that's going to be 3.5 or 35%. So the experimental probability is 35% higher than the theoretical probability. Theoretical probability, slow down, of 25%. Now,
Wouldn't it be like 10% higher?
that's the thing that you can say. There's a number of ways to say it. I'm just saying that it's higher than that probability. You could say it's 10% higher. The other thing is, depending upon the numbers, you can make more of a more focused type of answer. So I did this one for practice for myself. I did the same thing. I ended up with 2 instead of 7. Okay, and I did them one at a time, and I only got 2 1s instead of the 7. So it really was different. And what I said then was that the probability, the 10%, the experimental probability, is significantly lower than the theoretical probability. And that becomes, sometimes you may have to decide beforehand, what's a significant difference? Is 10% significantly different, or would you say 15% would be? You would decide that beforehand, and I didn't think about it before, I would have said that if our results differ by, say, 20%, then that's a significant difference. 15%, I don't know if I'd consider that significant. Some people might. 10%, I think 10% is in between. I'm not sure I consider 10% a really big, big difference. So I would say just that it's higher than or lower than, either by 10% or just give the amount. If it had been 40% at 15% higher, then I might say significantly or a lot higher. This one here, when it was, my first one was 10% and should have been 25%, that's a pretty big difference, I think. So I use the word significant there. So really that's sort of choice. You at least have to say higher or lower. So here I kept it as a simple answer. Okay, does this make sense how to do this?
Yes.
Let's take a look at the second one. So here, instead of just doing one thing, we're going to do a full probability distribution. Oh, this one's page 3. I took the wrong page out. Let's look at page 2. Find a probability. Candy company produces strawberry and vanilla flavored candies, 65% which are strawberry. Production on average. Production line mixes them randomly and puts 15 per bag. What is the probability that 7 candies in a bag of strawberry? Okay, here's how we figure this out. And we're actually going to go from here back to using the combination formula. So I'm going to do this, ENR, PR, Q, N minus R. If there's time, I want to go back to the binomial expansion and include that, as a couple of people were talking about 2 weeks ago. I think we should put that in. So I'm going to separate these out so we can look at and think of what they are here. So what this is set up as if it was a binomial thing, I guess you could say. So, we're gonna do a plus in here, and we're gonna do exponent. So we're gonna do this like a binomial expansion. So there were 15 candies in a bag. N is 15. So 65% are strawberry. Okay, what's the 7 candies that are strawberry? If 65% of them should be, that's what we would call the success of the first number. So we're going to put 65% here. And then the failures, the ones that are not strawberry, would be 35%. So P is the 65%. Q is 35%. So what I'm doing is I'm figuring out each of these parts. If the success, and that's the way you notice I did it, success and failure, they add up together to make 100%. So we're going to use those in here because then this one's going to be 0.65 because you have to move the decimal over, and 0.35. And we know the 15 is N. Now the R is going to be the number that we want, R equals 7. That means it's actually the 8th term. If we were to take this now, 0.65 plus 0.35 to the 15th power, and we now expanded that as a binomial, the 8th term would be the one that would give us 7 successes. So we're looking for when 7 successes are happening. So this one, 0.65 to the 7th power. The Q is going to be a 0.35 to whatever the difference is to make 15. That's going to be 8. And I want to start using this combination formula. 15 things, and it's essentially the way you say it is taking 7 at a time. Once you get those numbers in there, you're going to use the calculator for it. There's way too much here, especially with decimals and exponents, to do by hand. But before we do that, let's go back and focus on how I figured this out. You're going to use this formula, so you're going to need to know that formula, and we're going to go back and use that with the binomial expansion in a moment. But we're setting it up. You're used to seeing x plus y to some power. When you're doing a experiment like this, or figuring something like this out, the x is the successes you want, and the y are the failures you want. So you're still doing an adding, and this is the number of times that the number of things that you have in total. Okay. And then here what we get is just like when you expanded the binomial, this is just going to be easier to find the coefficient for it. Okay, we put that into the calculator. What I recommend when you do it is to just do this first and then multiply by each of these. So watch and see how I do it on here. In order to enter this, you have to put the 15 first. Then you go to the math key. Watch what I do here with this to probability. And this number 3 on here is a combination. Now, the differences between these we haven't gone over yet, so I hesitated to include it in here, but you really need it at this point. So right now, just go to it and use it, and then later on when we get to a probability lesson, I'll do more with that. But right now, come to that. So it's set up that this number first, that tells the calculator what the n is, and then the r here will be the 7. When I press it, it figures it out. What it's actually doing is 15 factorial over 15 minus 7 factorial times 7 factorial. And that's the way I had set that up in the binomial things, because by hand, that's how you do it. So this is doing a combination of 15 things, and you only want the 7th one, or up to the 7th. And this little shorthand is what you can use for the calculator. So that's 6,435. Now you multiply it by these, times 0.65 raised to the 7th power, and it will do the exponent before it does the times, of course. Okay. And then times the 0.35 raised to the 8th power. That's right, have I got that one right? Okay. So what we got was this number, 0.7103, so on. Make that a percent, 71%, because the 0.03 is too low to affect anything. The probability that 7 candies in a bag are strawberry is 71%. which makes sense. There's supposed to be more of them as strawberry. So 7 of them out of the 15, that's a little bit more than half, so that sounds pretty good. Okay, that seems to make sense for it. Yes?
I think the decimal is 0.071.
It is, yeah.
It is, you're right.
Should be 7.1.
It is, and I just wrote it down when I wrote it here. So thanks for catching that. Let's see if this is a better pen. There, that really gets rid of that. Okay, so 0.071. Now I'll move it over. So it's 7.1%. I thought 71% actually made sense because most of them are strawberry anyway.
Well, it would make sense if it was lower because if most of them are strawberry.
Yeah, that would be.
Yeah,
And
that's
7
right.
is technically less than half. Well, it's about half.
Oh yeah, it's less than, and come to think of it, it's only exactly 7. So that means if there's 6, or if there's 8, or if there's 9, or if there's 10, all of those are different ones. Added up, if you add up the ones, it makes more sense then that it should be a lower amount. So yes, that makes sense.
In
The way I'm-
reality too, it's like if it's supposed to be strawberry and vanilla, I've got 71% of them all strawberries.
Yeah, I guess it would be if it said something like 7 and more, because then it'd be 7 or 8 of them, or 9 of them, or 10 of them, or 11, all the way up to 15. Then it would be a much higher amount. And I guess that's what I had in my head, but I shouldn't have been thinking that. I should have been thinking just 7 only, so it is a smaller amount. Okay, so thanks for catching that about the 0. That's one of my failings on these, is I forget sometimes the extra 0 on these when it shows up. And it just showed up here. Okay. Now, I want to take this, we've got only a couple minutes. This last problem, I will actually work this one out and put it in Google Classroom tomorrow. So you'll see it's still using some of the same things we do, but I'm not going to do it right now. Because I want to go back over and have you practice one of these. Expand this to the first 4 terms and separately find the 18th term. So if there were time, I'd have you work it all out yourself right now. So what I'll do is I want you to start it and I'm going to work it through at the same time. So let's do this. Take the back of a piece of paper or grab a piece of paper back there, do something to have something to write on, please. And let's do this, x minus 2y to the 22nd power. So notice I say to the first 4 terms. On my test, I'm not going to ask you to do more than that just because way too much time, unless I make one as an outside of the class one. But I will make you do this on the test, but I'll only go to 4 terms because if you can do 4, then you know how to do all the rest of it. So this is enough for me to know that you do know how to do it. So the first term is always the number 1 times the x raised to the full number of exponents, and whatever the y, whatever is in the y place, raised to the 0. Plus the 22, 1 less here, and 1 more there. I'll calculate that out in a moment, because now we're going to have to use that -2 and multiply it to the 22. And for the third one, now this is where the method I personally like is to do, and I'll just do it up here. I like to do the 21 times the 23 and 1 times 2, and I can put that in the calculator. But this is where you can also use the method of the C and do it 22 of them. Okay? Now, interesting thing here is what we would do when I was setting it up. How did I write it up here? It's on here. Okay. This one, 22, and it's the 0. Notice I'm using that 0 for it here. You can get the 22 if you do 22C and 1. This one is going to be 22C and 2. Okay. And then x to the 20th, -2y to the 2nd. And then the next term, instead of doing this kind of thing, whoops, I should have put the 2 on here. So instead of doing this out, where it would be then 22 and 3, I would do 22C3, x to the 19th, negative 2y to the third. And then we would calculate it where this is 1, okay, 22, and this is where you see 22. So like this one, the 22C and then the 0 gives you a 1. So 22 is easy, let's do it with this one. 22, going to probability. Whoops, I pressed my hand, I should have pressed that. 22, that. So now I will put in, we'll do this one, we'll go right for that one that we don't know yet. And this is going to be 231. So I could have gotten 231 by doing this. 2 goes into 22 11 times. 11 times 23 is 231. That works well. But if I do farther, do more of them, it's going to be like a lot more. Can do the same thing with that. Let's do this before you go. I'll just do it really quick on it. To get the 18th term, we're going to basically set up one of these, but using this NCR. So here's the formula to use. NCR, PR, Q, N minus R. Notice we used that in that problem from the last section. So what we'll do here is determine in this one, the N of course is the 22, okay? And then we need to determine these other parts to it. The R, okay, it's the 18th term we want. The R has to be 1 less than the term. So it's 17. 1 less than the term, than the number of the term. So that's important. The P is going to be the X. Okay, P is X and Q is negative 2Y. So if you do 22C 17, X to the, this is R, X to the 17th power, and then negative 2Y, 17th power, negative 2Y to the 22 minus 17, so that's a 5, if I'm right. All right, 5, okay. And then you now have to basically just calculate this out. So on the calculator, you can do 22C17, and then you also have negative 2 to the 5th power that you'll have to multiply into that. I will finish that and post that tomorrow because we're out of time. Thank you very much for coming.